Hello everyone, my name is Jingtian Hui. My final project topic is about evaluation and analysis using different neural network modules for the topic of classification of animal species. My research problem is to study the feasibility of classification of animal species with neural networks. The goal is to compare the modules and select the best fitted one. I'm going to run multiple simple neural networks and also advanced neural networks such as CNNs using Keras in Python. Between the parameters, I would like to select the best combinations from the learning rate, momentum, hidden neurons, activation cost, functions, etc. Now let's talk about details about my dataset. The dataset contains 101 instances of animal species. It's not ideal that it only contains 100 instances, but it's a solid amount of dataset to run some predictions. The dataset contains 16 features of animals, such as the legs of the animals, whether it has hair or not, it produces milk or egg. The output has 7 classes, such as mammal, bird, or bugs or fish. To run the module, I would love to consider the parameters in the below, such as number of epoch, mini-batch, learning rate, different kind of activation cost functions using RLU or softmax. And for the advanced neural network, I like to compare the 1D and 2D convolutional layers. Now we're going to start with the simple neural networks. The simple networks I would like to consider about following parameters. I'm going to run 30 epoch with 10 mini batch. Consider my data set is not huge, so I think 10 will be really a good start point. I'm going to run really basic with starting from the learning rate at 0.1, the momentum at 0.7, and I'm going to run with 2 hidden layers with 64 hidden neurons in the first layer and 32 in the second hidden layers. Of course, I'm going to have 7 output layers based on how many output classes I'm having, and I'm going to apply softmax activation functions. So here is the changing parameters for different modules I'm going to run. I'm going to select the binary crossing trophy and the categorical crossing trophy, and also the optimizer will be changed on the module too. So I'm going to select from the SGD optimizer or RMS prop optimizer. The graph on the left shows 3 modules run. The first is combination with binary SGD, consider all the parameters stay the same. So the accuracy did increase as the epoch increase, and the loss decreased as the epoch increase. Now for the binary and the RMS prop combination is relatively better compared to the binary SGD because for the training and testing set, it all stay the same patterns that increase as epoch change and loss decrease as epoch increase. Well, the categorical SGD is that ideal because the training is relatively not predictable, and the testing accuracy is basically stayed constant. Even though the loss is relatively better, it's decreased. Take a look of evaluation of the accuracy. The RMS prop and binary combination produced the best training and testing accuracy that over 0.96 and the best test the loss. So I run the prediction one of the instances such as Theo. The output for that is 0.99 and target is 1, so that makes really good predictions. Going to the advanced modules, I did 2D convolutional layers with the same activation functions for both of the layers. I also did the same selection for the cost function optimizers. On the right-hand side of the graph, I ran the binary and RMS prop combinations that accuracy still increase as the epoch increase. Though the accuracy start decrease after the epoch 25, the loss still really consistent decrease and epoch increase. The binary SGD didn't that ideal. The accuracy for the training and testing set stayed constant, even though the loss decreased as epoch increase. So I think also consider the evaluation here for the test and training accuracy that still RMS prop and binary combination lead to the best training and testing accuracy and the really minimum loss. and I also ran the prediction on one of the instance. So this time I chose 1. The output is 0.291, and the target is 1. Consider other output and a target value. This also make a really good prediction about the instance to the species. So now I'm going to do, I think for the model I can apply some dimension reductions, as there might be some correlation collinearity between the feature, and that may increase the accuracy of the modules. So I think the convolutional neural network module returns the best fitting model with a higher accuracy that is over 0.98. I think that overall is really good predictions. I'm now open for any comments and questions about my project, and thank you very much.